Hello, ladies and gentlemen. Welcome to Chapter 20, where we are going to be talking about mixtures. And this is the first part. Now, before we get too in depth with talking about mixtures, let's do a couple of definitions as to how to describe the different types of mixtures. First off, heterogeneous, which is a mixture made of different substances, therefore a mixture. They are physically combined, so it's not a new substance, it's not a chemical reaction, and it looks different in different areas. So you actually will be able to see differences from place to place within the mixture. Hetero means other, genius, kind of beginning, or types or kinds. Okay, so you'll see different kinds of things in different locations. And on the opposite side of things, you have something is homogeneous, where you have a mixture made of different substances physically combined, but it looks the same all throughout. You can't see differences from place to place in the mixture. Okay, so first we're going to be talking about the different types of mixtures, and we are going to do what is called having them classified by phase. This has to do with whether it is a solid, liquid, gas, or how it combines together. Okay, the first phase is, or the first type of classification by phase is what's called an emulsion. And this is where you have two or more liquids, but they are distinct, they're separate. They are immiscible. They don't stay mixed. And you have the classic oil and vinegar for the salad dressing. But what you might not realize is things like milk and mayonnaise are actually also emulsions. If you look carefully at the picture of the milk containers, you can see the separation out between the milk and the milk fat. And you see the picture on the right where you have mayonnaise where it is separated out when you haven't added a chemical to help keep it mixed. Okay? When you read on your milk that it is homogenized, all that means is they have done a process to it so that it stays mixed, just like the emulsifier added to the mayonnaise. Normally these things separate out. They are an emulsion. Okay? Oftentimes, when they are mixed, they will appear cloudy. You can't see through them. Sometimes when they separate out, you can see through part of it. Okay, the next group, or classification, is what is called a colloid. And this is where you have a solid mixed in a liquid. Now, do not confuse this with a solution where you have like salt dissolved in water. This is quite different. And you'll know when you see the picture. Okay? There are two types of colloids. The first type is what is called a gel. And this is solid-ish. It's more solid than liquid, but it's not really one or the other. So these would be things like Jello and cheese and things that are similar to them. You know, you can pick it up, you can move it around, but it's not really quite what you would think of as a solid. You know, it has the ability to move and bend and squish and all kinds of stuff like that. So it is solid-ish, and it can dry out if you've ever had that experience with Jello or with cheese and other colloids. So it can do that over time. The second version of a colloid is what is called a sol. Okay? Do not confuse this. Do not think sol solid. Sol is liquid-ish. Okay? Things like ink, things like paint, they actually have solids in them, and what you think of when they dry, that's when the sol becomes a gel. Okay, if you've ever played with dried paint, you probably know it. It's like plastic. You can bend it and move it and stuff. It's a gel at that point. Okay, and the sol version of Jello would be when it's hot. Okay, so it can go back and forth between these two forms, depending on what the substance is. You're not going to, well, I guess you can melt your cheese and have it back in the sol form too. Okay, so it can go back and forth, but it goes between solid-ish and liquid-ish. Okay, so that's a colloid, a solid in a liquid. Okay, the third form, the third classification is a foam. And this is where you have a gas mixed into a liquid. Okay, if you've ever made whipped cream, you know you start out with cream, which is a liquid, and all you do is you beat it until you get enough air bubbles trapped in it so that it makes this whipped cream. Okay, that's the same way it works with shaving foam. You have a liquid and you simply trap the gases in that liquid. Eventually they settle out again so that the gas bubbles leave and you end up with this kind of melted looking goo, and it's no longer a foam, it separates. Okay, so that is a foam, a gas mixed into a liquid. Now the fourth type is an aerosol, and that's actually a term that we use on a semi-regular basis. This is where you either have tiny, tiny solids or tiny, tiny bits of liquids mixed into a gas. You're used to using this on things like perfume, cologne, air fresheners, things like that. We even talk about it with hairsprays and stuff like that. However, it also would include the clouds. It would include the dust that's in the air, all those tiny things that'll settle maybe over time, but they can actually stay mixed into the air for hours or days or indefinitely, depending on what it is. You actually can have dust storms or smoke and things like that travel across oceans and onto other countries. Okay, our last category for the day are alloys, which is a mixture of metals. Okay, for millennia, people have used different metals like copper, tin, iron, things like that. However, they have realized over time that by mixing these metals together, by putting their atoms together, you actually get new properties. It acts different, it looks different, it'll have different things about it. You can see the example here, copper and tin making bronze. You can see there's a color change even. Okay, you take that reddish and the silver and you get this kind of gold color. Okay, and with alloys you also can mix in solid particles like carbon and things like that in order to give different properties to the mixtures. Okay, we will talk again next time.